Good morning, good afternoon, good evening, wherever you are. I appreciate you attending this webinar, and we will get things started as soon as I can get the right button to click. We are pleased to welcome you to this Academy webinar series. We hope you'll find the next hour or so most interesting and informative. We developed our webinar series to deal with the technical and administrative issues that our customers face on a day-to-day basis. We recognize that the engineering challenges can be complex, and we're always looking for ways to support the technology industry. Before we begin, I hope you can see the title slide. This is part of our webinar series presented for the calendar year. We have muted everyone's microphone to keep the meeting quality as high as possible, and you may need to look for a full screen view. This can happen by you selecting by the way, let me read the slide properly. A recording of this event is underway, so you will be sent to all attendees, all registered attendees for this function. A full screen view may be preferred. You can select View Full Screen, and that way you'll see the full content more readily. To get out of that full screen, you can press Escape, and it'll take you away from that particular view back to the normal view. We encourage questions, and you can do that by sending us a chat or the Q&A comments. Address these to the host. I will collect these questions and answers and deal with those at the end of the presentation. We're not going to disrupt the speaker during the event, so we'll take care of the questions at the end, time permitting. We expect that the bulk of the presentation will take about an hour or so. We also always want to hear from you. You can contact Washington Laboratories, the Academy at WLL.com, with any of your training questions or concerns or ideas for us to present that may be a topic of interest. Our phone number is available at that place, and our website, WLL.com, can lead you into other training activities there. Or you may want to contact the speaker directly, Jay Moulton at rfexposurelab.com, JMMOULTON, email address. He will be more than happy to hear from almost all of our attendees. Let me introduce our speaker at this time. Jay Moulton is Vice President and Chief Technical Officer at RF Exposure Labs. Jay has been making SAR measurements since the inception of requirements for radio frequency requirements for portable devices. He is active on industry groups and consults with manufacturers and designers on the essence of SAR compliance. Jay's expertise in RF exposure requirements and compliance includes highly complex multiple radio configurations and operational modes for mobile phones, tablets, push-to-talk radios, Wi-Fi, hotspots, and related RF equipment. Jay, I welcome you to this. Let me hand you the control, and you'll be able to proceed at your own pace. Thank you for agreeing to speak for us today. And Jay, you have control.
Thank you, Steve. Well, welcome everybody. I know there's a lot of different time zones we're hitting here today. So good morning to those that are in the morning hours, and late night evening for some that are here in the States on the East Coast and the Midwest. Well, today I'm going to talk about SAR. I'm Jay Moulton. I work at RF Exposure Lab, and I pretty much run most of the SAR requirements for the lab here. This is all my contact information, and anytime you have any questions, you're welcome to send me an email, and I'll respond to all emails. Okay. There we go. What I'm planning on doing is I'm going to kind of start off with just a little bit of history of what SAR is and why it's measured and what does it really measure as far as when we're taking these measurements, what we're really looking at here. So first, what is it? Well, SAR is the amount of RF energy that's imparted in the unit of time to a unit of mass. So in other words, as you got a wireless device next to the body, the SAR is the amount of that RF energy that is formed from the device that's transmitting into the body next to the transmitter. So the total intake of that RF energy is actually a measurement of specific absorption, which is in joules per kilogram, and that's the sum or the integral of the SAR values over the duration of the exposure. So the longer the exposure, the more energy is going to be absorbed. The shorter the exposure, the less energy. So a lot of times people ask a lot of questions about duty cycles, and duty cycles are good because you're reducing the amount of energy that's actually being imparted into the body. Therefore, your average value is going to be lower, which actually helps you when you're doing your SAR evaluation. The specific absorption comes from radiology. It was really originally quantified for X-ray dose exposure of patients. So that's where it kind of came from. So, but the SAR, the specific absorption rate, is very specific just for RF exposure, and it's a matrix that we only use. Why is SAR measured? SAR is a measure of the reactive field, reactive near field of the antenna. So as the antenna gets closer to a body or to even next to a table, there's going to be a change in the reactive near field. It's disrupted based on the load of whatever it is that it's coming in contact with. And so the reactive E field energy does not propagate, but it is sensed by the E field probe, resulting in the higher readings. So when you put a device next to a body of tissue, the E field is not propagating through the tissue. It's actually just sensing the currents that are flowing within or close to the edges of the tissue. Reactive energy, it can be absorbed by the nearby bodies, but it's absorbed at a very slow rate. And the big thing that this is a big one that a lot of people, you know, whenever I get someone that asks me how do you reduce your SAR, you know, one of the biggest things is the reactive near field near E fields decay at the rate of 1/r² as you move away from the source. So as that antenna gets further and further away from the load, the body, the whatever is next to the antenna, the decay is 1/r², which reduces your SAR significantly with distance. So distance is one of the easiest things to reduce SAR, but not always the easiest one to implement into a device. And SAR measurements today are all being done with an E-field probe. We don't do any temperature measurements. They're all done with an E-field probe. I get a lot of people question me and ask me, well, what about the temperature measurement? The temperature measurement isn't done with low-power devices. So a large body in the proximity antenna can disrupt the antenna currents, which causes drastic changes of the radiated and reactive energy. So as you put something close to the antenna function and the antenna propagations are all changed drastically, which create a big issue when it comes to, number one, if you want to continue to make your connection. So you got to keep that in mind as you're doing design work for antennas, is to ensure that the antenna itself is designed to take that load. And one of the biggest questions I'm always getting is, if we do a free space measurement, can we predict what the SAR distribution is going to be and what the SAR value is going to be? It's not very easily predicted from a free space pattern, and that's because the loading and everything changes drastically as you get into that near field. When an antenna is put next to a human body, the human body actually becomes part of that antenna. The body itself will start to radiate some of the energy as well as the antenna itself. It comes right off the edges of the skin of the body. The electromagnetic interaction between the antenna and human body is a complicated item, and it's quite often it's hard to really predict what's going to happen when you start moving an antenna close to the body, and it changes every time. I mean, every body is different, so even if you put an antenna next to one person, it'll react one way, and you put it next to a different person, it'll react completely different. And the RF currents are excited over the body as it gets closer to the body, and that's how the antenna is, or the body actually becomes part of the antenna, because the body itself starts to get excited with the RF currents, which then allows them to launch and radiate. Okay, so a little bit of the history. SAR was introduced in the early 1970s, and it was used to quantify the amount of exposure that the diathermy patients were receiving, and it was introduced by Professor Guy of Washington University. Now, Professor Guy actually used thermometers and measured the tissue, the heat in the tissue, to determine how much SAR was being implemented into the patients. And so that's kind of how it got started, was with the thermometers and with temperature rise, and that's how everybody kind of hears about the temperature rise and why everybody wants to see a temperature rise number. And Professor Guy then suggested the use of SAR for push-to-talk radios initially, because they're high-powered radios that you could use the thermometers to actually get a measured increase in the tissue temperature. So this kind of gave rise to the first SAR measurements, and it was in the late 1970s when all of this was started and the PTTs were being tested and at least being evaluated. Motorola was one of the first ones that really got started in that in the 70s. However, with the introduction of the cell phone, the power was so much lower, the temperature measurements were unreliable. They really didn't give numbers that were valid based on using a temperature measurement. So with the cell phone, SAR needed to be made by the E-field measurements within a phantom. In the early 1990s, the first liquid phantom material was developed at the University of Ottawa for use in SAR measurement. They actually used, the very first phantom that they ever used was an actual human skeleton in which they just wrapped basically a balloon around the skeleton head and then filled it up with tissue, the simulated tissue, and took a probe and took measurements within the skull. Obviously today we don't have that. We have the SAM phantoms that are all simulated devices for test purposes. The small RF transparent E-field sensor was actually developed by Howard Vasson of the FDA. That's really the first design that came out with the orthogonal sensors, which is still basically used today in all of the SAR probes, where we use 3 orthogonal sensors on an H-beam support. And that probe basically set the framework to start measuring SAR at that point. So devices that require RF exposure testing. Well, all devices with a transmitting antenna must be evaluated to RF exposure requirements. You know, a lot of people say, well, my device is greater than 20 centimeters, I don't have to do anything. Now, it still has to be evaluated. It's just you're now evaluating to a mobile device rather than a portable device. But if you've got a transmitter in a device, it has to be evaluated for RF exposure requirements. And some of the new technologies that are coming out, there's a lot of clients coming to me and asking questions and saying, well, I'm at 60 gigahertz, there's nothing out here that says what I have to do. And that is true. The 60 gigahertz is still undefined as far as what has to be done, but there is stuff that has to be done, and the FCC is actively evaluating and granting devices that are operating in the 60 gigahertz, both as a mobile device as well as a portable device. It's just that it's not an easy task to get a lot of those types of devices approved because it is a new technology. But it is a transmitter, therefore it has to be evaluated for RF exposure. There are exclusions for specific countries that can be taken into account to determine what is required. The FCC has a formula to determine whether you have to do a test on a specific device. It's based on the transmit power, the frequency, and the distance the device is from the body. Europe has just a single number. They just, anything over 20 milliwatts, they want a SAR report. Anything under 20 milliwatts, they don't require a SAR report. Industry Canada recently with RSS 102 issue 5 coming out, they completely changed their direction, their numbers. They have specific numbers, and then you just interpolate in between based on distance. Their numbers are much more conservative than the FCC's, so quite often you may not have to do testing for the FCC, but you might still have to do testing for Industry Canada. And just kind of for classification purposes, any devices that are normally used 20 centimeters from the body, those are classified as a mobile device. And anything less than or equal to 20 centimeters are classified as a portable device. And for mobile devices, you only have to do an MPE evaluation. For portable devices, you have to do a SAR report. So these are kind of the headlines of what I'm going to kind of get into as far as for testing and requirements at this point. I'm primarily going to be focusing on a lot of the FCC requirements only because as far as requirements and definitions, the FCC has defined things much more strict than most of the rest of the world. Most of the world pretty much follows the EU requirements, which you have a little bit of latitude in engineering decision-making possibilities as you're doing the testing and the evaluation, whereas the FCC pretty much dictates how everything will be tested, and you really don't have a lot of latitude in that. If there's not a specific guidance that tells you you can do it in a specific way, you really have to get guidance from the FCC before you move on. So that's kind of why I'm going to kind of focus a little bit more on the FCC side of this. So as far as U.S. standards, these are the primary standards that are used today for the different requirements within the United States. You've got the NCRP report number 86, which is basically very similar to the ICNIRP standard in Europe. You got ANSI 95.1, which covers the full band of what has to be tested and for devices that are within a distance of the body. And then you've got the environmental assessment requirement for CFR 47 1.1307B. And the environmental assessment is basically, that's primarily more for devices like base stations and so forth that are out and away from the body, but there has to be an assessment made. And then 1310 out of CFR 47.1 is the MPE limits. And then the FCC OET Bulletin 65 is an obsolete document. I still get a lot of clients that come to me and say they have to meet this requirement. The Bulletin 65 was obsoleted about 2 years ago now, so it's pretty much completely gone at this point. You don't have to meet the requirements of Bulletin 65 anymore. All those requirements are pulled out and put into various KDBs within the KDB system. And then here's the two requirements for the MPE and SAR. That's where the FCC calls out for meeting the requirements of MPE in CFR 2, 1091 and 1093. Excuse me. Those two paragraphs within the CFRs are basically the law that you have to meet either the SAR requirements or the MPE requirements before you can release a device within the United States. And then the FCC has many KDBs released for SAR, varying depending on what your device does, how it's used, how it's operated, and so forth. And so all of the KDBs then also cover a lot of the SAR requirements. And this table here is the FCC MPE limits for a controlled environment. The controlled environment is very difficult to get approvals with. The FCC only allows certain types of devices to be considered under a controlled environment, And in order to get that done, there has to be a lot of training, specific training to RF exposure requirements and RF exposure safety to ensure that the end user is well educated in protecting themselves. So these limits are used, but primarily for devices such as push-to-talk radios for the police, the fire department, and other safety organizations. But when you start getting into devices that for even a family radio, they can't meet these requirements because you just can't get the training in place. And then here are the ICNIRT's limits for the same controlled environment. Again, you know, they have much more, their limits are completely different from ours, and they have a lot more bands that they set their numbers in, and a lot more measurements that have to be done in order to meet the requirements of the controlled environment. And then for the SAR, for the controlled environment, you've got the head and the trunk, or the body. The US and Canada is 8 watts per kilogram averaged over 1 gram of tissue. Again, this is for the controlled environment, not general population. And then the EU and the rest of the world uses 10 watts per kilogram averaged over 10 grams of tissue. Now, the rest of the world includes pretty much everybody except Korea. Korea tends to follow the FCC limits, even though they use the EU test methodologies. So there's a little bit of a disconnect there. They're the only country that they actually use the 1.6 for and 8 watts rather than where the rest of the world uses the 2 and 10. So, and then for the hands, wrists, feet, and ankles, which is considered the extremities, the US and Canada is 20 watts per kilogram, averaged over 10 grams of tissue, and the EU and the rest of the world is 20 watts per kilogram, averaged over 10 grams. And the hands, wrists, feet, and ankles are very specific. It has to be very specifically, and it cannot go up the arm. It's just right at the wrist, the hands, the feet, and the ankles. And the limit is much higher just due to the fact that there's no muscle in that area of the body. The extremities are all primarily cartilage and tissue, or cartilage and bone. So therefore, the limits are much higher. I get that. Okay. Now I'm going to kind of get into some of the. Oh, that kind of went way over. Okay. I'm going to get into some of the KDBs and the implementations. There's some slides that are missing on this one. Well, I'll real quickly go over the requirements for the general population. For head and trunk and body, it's 1.6 watts per kilogram averaged over 1 gram of tissue. The rest of the world is 2 watts per kilogram averaged over 10 grams. And then for the hands, wrist, feet, and ankle, it's 4 watts averaged over 10 grams for both the EU and the rest of the world. So those are the limits for when you go into for a uncontrolled environment. For the KDBs, the primary KDB for the FCC that is for SAR requirements is KDB 447498. It's called out on just about everything. It kind of determines what testing has to be done. For this particular slide, I'm kind of getting a general idea, or giving a general idea on the transmitter modular approval. The first thing you have to do is determine how that module is going to be used if you're going to do a transmitter modular approval. You can either be mobile only, portable only, or mixed mobile and portable. Any module manufacturer, if they're going to go through SAR testing, they really should have their modules always approved for mixed mobile and portable. It makes it much easier as you go through the process and do any type of Class 2 permissive changes, that it will keep the whole file operating, because then you can have both types of devices within the same filing. There's no restriction on what can be approved when your 1 gram SAR value is less than 0.4 watts per kilogram and the energy coupling SAR is less than 0.45. I'm not sure. That doesn't make sense. Okay. And so basically here, if you've done a test on a portable, on a module, and it's a portable device, and you've got all the numbers, and you've got everything less than a 0.4, you can take that module and put it in any type of a device, cell phone, laptop, tablet, anything, and you would not have to retest as long as you meet the minimum test distance of 5 millimeters. But if the minimum test is less than or equal to 5 millimeters. When the highest reported SAR is greater than 0.4 and less than 0.8 watts per kilogram, it can be qualified for multiple host platforms, but now what you have to do is you have to go out and you actually do testing in the host, in some sampled host devices to show that the device does function the way it should and that you can still get those lower numbers. So this would be something that, say you get a point, you stay below a 0.8, then you can put it in, let's say you do a bunch of testing in tablets and laptops, you can put it in those same host platforms as long as you can meet the grant notes of being less than the distance from the antenna then that was originally tested. As long as you can meet that requirement, then you can go ahead and still put that module into a laptop that has, let's say you met the 0.8 requirements with a 10 millimeter gap. Then as long as you can maintain a 10 millimeter distance between the antenna and the user in a tablet, then you can go ahead and put that module in the tablet and not have to go back through SAR testing. If you can't meet that minimum distance, then you have to go back and do the SAR testing. So you just have to be able to meet the minimum requirements. And then as far as if it's greater than a 1.2 when you do your modular approval, so let's say you wanted to get very close distance, but it's greater than a 1.2, it's dedicated to a specific host's approval. And you may have to go back and do a lot more testing still, even though you've got a modular approval for SAR. Okay, we got some of them got switched around. So here's the uncontrolled general population for MPE for the FCC. This is the limits for the MPE requirements in order to determine what you've got, whether you pass for an MPE requirement. And then this is for the ICNIRP for the US or the EU, which is their uncontrolled, which is the general population. So the limits here are much tighter and lower than what they were for the controlled environment. And then here are the SAR values for the head and trunk. It's 1.6 watts per kilogram averaged over 1 gram of tissue. And then there's, for the EU and the rest of the world, it's 2 watts averaged over 10 grams of tissue. And then you've got the hands, wrists, feet, and ankle, which are both 4 watts averaged over 10 grams. Okay, so the evaluation methods, you've got portable devices, which for the purpose of the section of 1093, a portable device is a device that is transmitting within 20 centimeters of the body of the user. So devices like this are cell phones, tablets, hotspots, pretty much anything that is, a lot of medical devices are now falling into this because there's many medical devices that are putting wireless within the medical device itself. Implants, all of those types of devices will fall under being a portable device. Multiple transmitter systems, this is kind of a tough one. With SAR, we still look at each transmitter individually. We do not do the testing with multiple transmitters operating at the same time. And then there's a couple of options. We either sum the values, and as long as we're less than the limit, we can consider that to be that the worst case mode will pass the SAR requirements. So you meet the simultaneous requirements by doing a summing of the values. If you can't sum and stay below the limit, then there is the ratio, the separation ratio distance that is evaluated, and it's the distance between the two hotspots. And you do a calculation, and if you're below the 0.4 or 0.04, then for the calculation, then again you can be considered to pass the simultaneous requirements. And then if neither one of those happen, then you've got to do the volume scan, which a volume scan is a little more time consuming. And basically what you do is you have to do across all of the, you do an area scan across all of the antennas so that you cover the full area of both, or however many antennas there are. And you do that for each of the different transmitter bands that gives you the highest numbers. And it actually does more like a zoom scan or a cube scan, where it does the area, but it does multiple 7 or 8 measurements coming out of the tissue at each and every point. And then once that's completed, you take both from the multiple transmitters, you take all of the data, and you just sum all of those separate points within the two measurements. At each individual point, you sum up all the values, and then you reevaluate what the SAR value would be overall with two transmitters operating at the same time. Which typically, if you've got any kind of distance between the two antennas, it's pretty easy to pass that requirement. It's time consuming to have to do the test, but it's not a difficult one as long as there is some distance between the antennas, because it's a rarity that you have much energy being propagated out that far across between multiple antennas. Okay, that's a slide we just went over. We just finished that one, even though it was out of order. And then here I'm kind of going over. This is cautions and labels for avoiding unintended use conditions only. You can't use a caution or a label to tell someone not to do something in order to get out of meeting SAR, or not to be able to pass it with by saying, oh, don't hold that cell phone closer than 5 centimeters from your body. The FCC doesn't allow that. You have to be able to do the testing in what a normal use operation would be, and you have to pass at that level. You can't use any kind of cautions or labels to get out of SAR testing. Your occupational limit, this is where I was kind of talking a little bit. Users must be fully aware of their exposures, and it requires exposure testing or training. So that the training itself is very in-depth and has to be well covered in order to allow the device to be considered an occupational limit. Source-based time averaging, all of the SAR testing is done using source-based time averaging. You do the measurements at the maximum conducted power for SAR, and in SAR, and this is where I fight a lot of times trying to get clients to understand, I need a tune-up procedure on their transmitter. I need to understand what their upper limit is, and the transmitter, when I'm doing the testing, must be within 2 dB of that upper limit. So if they've got a really big big tolerance on their tune-up procedure of something like plus or minus 3 dB, then it's going to be difficult for me, because if I get a device that's at the lower end of the tolerance, it may not be within the 2 dB requirement of the upper limit. So that's where one of the things that when I get a device, the first thing I have to determine is to make sure that they've got enough power coming out of the transmitter that they're within 2 dB of the upper limit of the tune-up procedure. And then for SAR, once we do our measurement, we have to scale the SAR value to that upper limit of the procedure. So if you've got a 2 dB gap between what was tested and what is the upper limit, it can be very difficult to pass when you're starting to scale a SAR value up by 2 dB. It really pushes the number up pretty fast. And for testing, you have to test each frequency band and configuration. And this is for this one here, what you have to do, this is a repeated measurement. The FCC requires that you have to repeat any numbers that are greater than 0.8 in every frequency band and configuration, and all the values that are above 1.5 watts per kilogram. So that just they added more measurements in the test requirements about 2 years ago, and that's just a requirement that they now have. For implant devices, if your device transmits either the radiated or conductive power is less than or equal to 1.0 milliwatts at the antenna port or the radiating structure, then there is no SAR requirement. You can be excluded from actually having to do a SAR measurement, or in this case, a FDTD evaluation. Nothing is required. All you have to be able to show as proof is that your device cannot exceed 1 milliwatt in power. For standalone SAR test exclusion, this is the calculation that you would use to determine if a transmitter is excluded. So this calculation is only for devices that are used within 50 millimeters of the antenna, or the body, between the body and the antenna. It's less than 50 millimeters, and you would use 5 millimeters for the equation if the distance is less than 5 millimeters. So you pretty much just have to put in the maximum power, divided by the minimum distance, and multiply it times the frequency in gigahertz. And that number has to be less than 3 for 1 gram and less than 7.5 for 10 gram. And those numbers are good from 100 megahertz up to 6 gigahertz. And if you're greater than 50 millimeters, then you'd use the second equation, in which you'd have to do the equation. The first, it kind of ties the two equations in together, and then you would continue on. And then if you're greater than 50 millimeters but less than 200 millimeters, then you have to do the very bottom equation. And if you can meet the requirement to where you're excluded, then you just don't have to do testing on that specific transmitter. So if you've got multiple transmitters, Wi-Fi and Bluetooth in one device, and your Bluetooth is excluded, but your Wi-Fi is not, you still have to do your SAR testing on your Wi-Fi. And so that would be still a requirement to do whichever technologies are not excluded. Now, if you do happen to get it excluded and you have a simultaneous requirement, for instance, Wi-Fi and Bluetooth, and they both can transmit simultaneously, and you've excluded the Bluetooth from requiring to do any SAR testing, but you do have to still do testing for the Wi-Fi, and then you have to still determine about your simultaneous requirements. So in that case, you have to estimate what your SAR value would be for your excluded transmitter. So for a Bluetooth transmitter, you would use the maximum power of the channel divided by the minimum distance, and then you'd multiply it times the square root of the frequency in gigahertz divided by 7.5 for 1 gram and 18.75 for 10 grams. That will give you a value of watts per kilogram. And then that number is what you have to use to do your evaluations for your simultaneous requirements. And then if you're greater than, and that's for anything less than or equal to 50 millimeters, if you're greater than 50 millimeters, you just use 0.4 watts per kilogram for 1 gram and 1 watt per gram per kilogram for 10 gram average. And then for determining what the distance is between the two hotspots, since you don't really have a hotspot for the excluded transmitter, then you would just take the feed point or the center of the antenna, whichever is more conservative, to determine your distance between there and the hotspot of the other transmitter. And you know, if the number comes out real high and you don't have a lot of space to do the addition, you can test the transmitter that's being excluded if you choose, and just put it in the report. And then for the simultaneous transmission SAR exclusion, this is where if you can sum the two together and they're less than the limit, you're good to go, you're finished, your simultaneous meets the requirements. If you cannot and you have to do the separation ratio, the equation is there for each pair. So you work each pair through the whole system if you have multiple transmitters, and it's just SAR1 plus SAR2 raised to the 1.5 divided by the radius between the 2 points, the distance between the 2 points, and that has to be less than or equal to 0.4 for 1 gram and 0.1 for 10 grams. This has been a real big problem here lately, aftermarket accessories. Technically, by the FCC requirements, any aftermarket devices that are attached to any kind of a transmitter has to be evaluated. There's a lot of stuff on the market that is not being evaluated, has never been tested, and there are problems with the things, simple things as a cell phone and putting a plastic case around the cell phone. The cell phone is designed to be with nothing around it, and the antenna and the SAR values are all based on that phone alone. As soon as you put a plastic case on it, that plastic or whatever the material is has a different dielectric than what that antenna is used to seeing, and it changes the SAR values. I've done some testing in the past with before and after on cases, and there's a lot of cases that actually, when you add the case, it increases the SAR value, which is not a good thing considering people are putting cases on everything. So by the FCC's rules, all those devices are supposed to be evaluated. However, very few are being evaluated. The only ones that seem to be getting any evaluation at this point is someone that actually put some sort of a transmitter in their the case that goes on to the phone and acts as a secondary transmitter. Then at that point, it has to go through an FCC evaluation, which then they have to go out and do a whole bunch of SAR testing on the phone as well as their device. They don't, you know, their device is part of the evaluation, but they also have to do a lot of testing on the phone itself. The mobile exposure conditions, these are all just the requirements for mobile requirements, the E&H field strength, when they're less than 300 megahertz, and then your plane wave, this is when you would do E&H field power strengths if your transmitter is less than 300 megahertz. You do a plane wave of equivalent power density when you're greater than or equal to 300 megahertz. And when MPE testing is required, you test in both the vertical and horizontal planes, and you test along the radials from 45 degrees apart, from less than or equal to 30 degrees if it's greater than 20 centimeters. There are instances where MPE is required. The FCC has certain power levels in which they will not allow you to do an evaluation, that you have to do a physical measurement. And so you just want to keep in mind that if you have to do a measurement based on the power level of your transmitter, you do have to do the measurements following these guidelines here. And that was, as mentioned earlier, all transmitters require RF exposure requirements or evaluation. So the first thing that you want to do is determine the type of device you have, whether you're a portable device or a mobile device. And then the second is to determine if there are any exclusions that may apply. You want to take into account any duty cycles you have, any, if you've got low power, if there's exclusions based on the distance the antenna can be maintained from the body, You want to get all of those exclusions done first, because you really don't, if you can avoid SAR testing, you want to try to avoid it as much as possible, because SAR testing, you know, depending on the device, sometimes it can be very difficult to get them to pass the requirements. The third item is to determine a test plan to meet the RF exposure. You know, if you can come up with any kind, if you're early enough in the design cycle, you can kind of design things in to meet the requirements. If it's at all possible to do that, it's best to be at the front end rather than at the back end, because once you get to the end and you're doing the testing and you fail, now it's much harder to get any kind of design changes that might get you to where you can pass the requirements again. And any and all of your exclusions has to be documented and filed with the regulatory agency. So when you're doing a Class 2 permissive change and it's determined that you are excluded from having to do SAR testing for a specific device, you have to show and document how you are being excluded, and you file that in the place of a SAR report in the RF exposure exhibit. I know there's a lot of people that are not doing that, but that is something that, you know, because you're excluded, and that's fine. You don't have to do anything. All you have to do is show proof that you are excluded and how you're excluded. And so you have to file that. And even if your device is such that you're putting a Bluetooth in a device that's a headset and it's completely excluded, you still have to do a Class 2 permissive change because you have moved that modular approval from a mobile device to a portable device, and you have to show how you're doing that to meet the requirements of a portable SAR requirement. Common design and construction. These are just some general things that can help in design work. Your antenna placement, obviously, the largest gap possible will give you the best performance or best ability to pass the SAR requirements. The closer the antenna is to the body, the higher your SAR value is going to be. Your radiating pattern, if you can kind of generally push most of your energy away from the side that's normally going to be next to a body, then you can avoid getting as much energy going into the body and getting more energy going away from the body. But it just kind of, it's still kind of an issue even with that, in that you've still got a lot of current flow that's close, but if you can push it off to one direction, it does make it a little bit easier. Your VISWAR, the better your match, the better your SAR. If you've got a really poor match, your SAR value will go up with the mismatch of the VISWAR. And then obviously your power plays into it. If you can reduce your power at all and still meet all of your other requirements, that always makes SAR a little bit easier to pass than if you have to stick it out and make it at a full power. Component radiation devices, shield cans and power ports are two of the hottest things on a transmitter. The cans, if they're not properly grounded, can very easily start radiating, which will give you a lot of current flow and will be a big problem when you come into SAR, because it pulls that current right up closer to the outside case. Power ports or any kind of vias within a board that is carrying currents and the RF power, those tend to radiate and can give you some really high numbers as well. Shielding, I mean, that's always an option if you can. Metallized paint, you just want to make sure that it's properly put on, because there is some metallized paints that if you do it incorrectly, it'll actually be worse rather than better. But you can use the metallized paint. In the past, I've even taken metallized paints and basically tuned it to pull the energy into two different sections on a case, so that we had two hot spots rather than one, to reduce our SAR value that way. By having two hot spots rather than a single higher number, it split it down into two, almost 3 dB lower between the two of them. And then absorber, if you have the space and you can put in absorber helps to absorb some of the currents and to lower the SAR value if you can. And that's it. If you've got any questions, I will take the questions at this point.
Well, Jay, thank you very much for your presentation. I did receive a couple of questions here. Hopefully we'll be able to take care of this. One of the questions, how co-location exposure is evaluated when one radio is SAR condition and second is MPE condition?
Okay, what you have to do at that point is if it is an MPE, if one of them is an MPE and one of them is SAR, you still have to evaluate the second one, the one that's the MPE, as if it were a SAR value. So then what you would do is you basically, it's still excluded from SAR because it's MPE, but you would do your evaluation to determine what the SAR number would be if you had to do a measurement on it, and then you would sum or do however you would do where you do the summing of the two transmitters at that point.
Okay, another question. How about MPE for a Bluetooth and Wi-Fi radio during simultaneous transmission?
Well, if you're doing MPE, it's basically the same. You have to do the MPE evaluation of each of the individual transmitters, sum the two together, and you have to stay below the MPE requirement.
Okay. Does the EU standard require scale-up SAR similar to FCC?
No, they do not.
Okay. You mentioned temperature measurements, but not applicable to low-power devices. Does SAR apply to high-power devices, and what is that power level, and is temperature required for those devices?
The temperature is, the temperature evaluation is the basis of SAR testing. It's just that low power devices such as cell phones and most of the transmitters today that we use are really considered low power devices. Those devices are, the temperature did not give a reliable number, so that's why we switched to the E field. But the temperature is still technically valid for even the low power. It's just that it doesn't give a reliable enough number. So that's why the industry switched to the E field. And as far as the E field is a very reliable number, and it can go all the way up to high power devices if necessary. Pretty much anything above about 1 watt or 2 watts in a general population requirement would not pass, depending on the band that you are. So it's kind of limited. The SAR kind of limits how much power you can get out of a transmitter and still meet the requirements. But the E field measurement is valid up to full high power devices. It can do a 200 watt device if it wanted to.
Okay. In market surveillance, the SAR reading from sample is compared against the limits of the scale-up SAR. That's the question.
Repeat that again?
In market surveillance, the SAR reading from sample is compared against the limits of the scale-up SAR. Is that correct? Yes.
If you're doing a market evaluation, if you're doing a market surveillance evaluation for SAR, when you retest the sample, the audit sample, it basically, you're still going to scale it up to the high end of the tune-up procedure when you do the audit, and then those two numbers are compared to determine are they within a reasonable distance of each other based on the fact that it's not the same device, it's tested at different times.
Okay. Does EU require testing tablets for 6 sides or 5 sides like FCC?
Actually, the EU requires that on every device. The EU requirement is you test all sides of an antenna. If you look in 62209-1 and -2, it calls out that you test all sides of an antenna. Now, that being said, the one thing the EU does allow you to do is to do an evaluation, and you can look at the different distances of the antenna, and if if you're testing one side that is 10 millimeters and the other side's going to make it 80 millimeters, you can exclude having to do the 80 millimeters, and you can justify that in your report.
Okay. That's the questions that I currently have received. I do want to go over a couple of things regarding upcoming training while we give everybody an opportunity to submit another question. So with that being said, I'm going to take the control and go through another slide here. It says I'm the presenter. We at Washington Laboratories, and I'm going to change the slide. We have a lot of immediately coming up training in the next week or two, and some a little bit further away. I do want to go over a couple of our topics just to kind of give you a feel for what's going on currently, and then we'll check for questions again. We have a product safety session dealing with thermal measurements. This is part of a 12-part series on electrical and product safety evaluations. September 14th, we have a mill-centered 461G. That's a session dealing with area 101 and 102, part of a 12-part series presented this calendar year. And the 461G hands-on course, scheduled for September 20th and 23rd, has 2 more seats available. So we'd be happy to entertain that. It's a 4-day hands-on course at our Gaithersburg, Maryland facility. Mill-centered 810G comes up September 15th, dealing with some atmospheric tests. This is another 12-part series dealing with some of these mill standard requirements. We also have another wireless session coming up September 20th on broadband wireless devices. I think our speaker for that is Mr. Michael Young, very knowledgeable in this particular arena, and I look forward to seeing that one. And October 11th, we dealing with some IEC CISPR testing, dealing with the IEC groups, and we're going to focus on the Electrical Power Research Institute Technical Report 102-323 Revision 4. That's the current standard issued by them, or guidelines. And we also realize that the NRC for Nuclear Commission is looking at this very closely, and they're updating the Reg Guide for safety equipment. We also do a lot of training to replace your hours, so don't hesitate to reach out if you have a particular training need. You can contact the Academy or me, Steve Ferguson, stevef@wll.com, and we can address your questions and concerns. I do want to do a quick look. Looks like I received another question while I was off doing that, so let me, Jay, they ask, can we get a copy of the presentation? The presentation will be sent, and a link to this recorded event will be sent to all registered attendees. If you're not on a registered list, then you will not be receiving that. So just to be sure that, if your name doesn't appear as one of the attendees for a group session, then you won't get it directly, your group leader will. So that's the case. I've also got another question that's popped in. In market surveillance, the scale-up SAR reading from sample is compared against the legal limits or against the previous scale-up SAR on the filing. Jay, that would be for you.
It would be compared against the previous test to ensure that basically the audit is just checking to see is the device still within general specification. If you're lower than what was originally tested, there's not going to be an issue. But if you're higher than what was originally tested, that's when things start getting a little more questionable as far as any kind of issues.
Okay. Well, I think we're almost out of time, and I don't see other questions appearing at this. So I'm going to thank you, Jay, for your fine presentation and dealing with the questions that come in. I look forward to working with you in the future on these types of things, et cetera. We at Washington Lab certainly appreciate your participation in our webinar series and the expertise you bring to this event. With that, I do not see other questions, so I'm going to close the event. We look forward to seeing all of you at future events. Please check our website for issues that may come up. I just saw a red flash on my control. Nope, it says people are logging out. So with that, I'm going to go ahead and end this event. Thanks again, Jay. I certainly appreciate your participation.
Thank you.
So this event will end in 3, 2, 1. Thanks all.